Worksheet 7. This will be video number 1, so this will be problems 1, 4, 7, 10, etc. And somebody stop me if I start adding 3 wrong and get off on the wrong pattern here. Number 1, calculator. The test is no calculator. We'll still do this because this is still helpful stuff, but again, the test is no calculator. An open top box is constructed by cutting squares that are x inches by x inches from the corners of an 11 by 17 rectangular piece of cardboard. Okay, let's see if we can figure out what's going on here. 11 by 17 piece of cardboard. We're going to cut corners out that are x wide, or x long, or x long and wide, I guess. And then folding the sides of the box up to make the walls. The volume of the box is modeled by the function v. Which of the following statements is true about the function v? Well, let's see if we can figure out what the function v is. So the volume is length times width times height. After it's folded, though. So after it's folded, this is or one of the dimensions. How long is that after I fold it? Good. 11 minus 2x is that dimension. And then after I fold it, what's this dimension? 17 minus 2x. And how tall is the box after I fold it? X. So there's my function v that it wants me to ask questions about. The contextual situation, that sounds fancy, restricts the domain of v for x to be between 0 and 17, and the relative maximum of the v on this domain is 6647. This is because the longer side, hold on a second, the domain, what about my x value? What can x be for this thing to actually work? What's the biggest x could be before I lose my box? What's that? 5.5. Right? Because if x is bigger than 5.5, then I've cut all the way through and there's no base left. It's all wall. So no, not 0 to 17. That would not work. Not 0 to 11. Not 0 to 8.5. 0 to 5.5. So I don't even need to read the rest of this thing. I'm restricted to 0 to 5.5. Because if I cut any more than that, that doesn't even make sense. 5.5 is the widest or the biggest x could be, because that would get me all the way to the middle. Number 4. So yeah, that it says calculator, but you didn't really need a calculator for that because the differences in the answer choices. Number 4. The functions f and g are given by those two things. Which of the following statements is true about the remainder when f is divided by g? When f is divided by g. Ooh, we haven't done one of these in a while. And by that I mean, can I synthetic divide on this guy? No, because there's an x squared, so this is just going to have to be old school 4th grade long division here. I'm missing an x squared term, so I probably want to put a placeholder in for that. 3x squared minus 2x. And I'm looking for the remainder. And potentially there's not a remainder, we'll see. So something times 3x squared gets me 6x to the 4th. That would be 2x squared. So 6x to the 4th minus 4x cubed. Draw the line, change the signs. So 9x cubed. And then bring down the rest. something times 3x squared to get me to 9x cubed. That would be 3x. So multiply it back, I get 9x cubed minus 6x squared. Draw the line, change the signs. First term goes away. It should always go away. You forced it to go away. So 6x squared plus 3x minus 5. It's not looking like the remainder is going to be 0 here. It's just too many terms left. Something times 3x squared to get to 6x squared would be 3. No, it would be 2. 2 times 3 is 6. 6x squared minus 4x. Draw the line, change the signs. So 7x minus 5 is my remainder, which means g of x is not a factor of f of x. Right? If you get remainder 0, that would mean it's a factor. Long division. Number 7. The function f is given by this thing. Which of the following correctly describes the end behavior of f as the input values increase without bound? So let's look carefully here. All of these are x goes to whoops. So the first two are right end. And the next two are left end. Right? X goes to positive infinity, x goes to negative infinity. Okay, on the right end, I'm trying to think why I'm not going to get two answers to this. We'll see. So as x goes to infinity, what's the right end doing? Is the right end going to be up or down? Down. Why is it going to be down? That negative lead coefficient means the right end is going to be down. So that means as x goes really far positive infinity, we're headed toward negative infinity. So I think B is right. A is definitely not right. Now the way that's worded, as the input values increase without bound, that means I'm going to the right end. That doesn't mean I want to know what's going on at the left end. Let's go ahead and answer it just to remind ourselves. So what would the left end be doing? Up or down? Uh-oh, heard both. Why up? Yep. Odd means opposite. Opposite of the other end, so left end would be going up. So as we go toward negative infinity, we'd be headed toward, the graph would be going up, so toward positive infinity. So C is a true statement, but it doesn't answer the question. Right? So C is true, but it says increase without bound, so that would be x going toward infinity. So, tricky question there. B and C are both correct, but only B answers the question. Number 10. A polynomial P is an odd function. Oh, we did one of these yesterday. What does odd function mean in terms of symmetry? Origin, which is 180 degrees if we're trying to think how to draw this thing. P of 3 is negative 4. P of 3 is negative 4. Is a relative maximum, so the top of a hill. Which of the following is true about P of negative 3? Again, my picture doesn't have to be great, but if I rotate that thing around, it's right there. It looks like that. So P of negative 3 would be positive 4, and it would be a relative minimum. So answer choice C. Given the time constraints on the test, you need to be able to answer that pretty quickly without taking forever. Number 13. Average rate of change of a quadratic function is -4 on an interval. And then, okay, this is one of those interval questions. So the average rate of change won't be the same, but the next difference of the average rate of change will be the same. So I like laying out my information. Maybe there's a better way to do this, but so from 0 to 2, maybe just trying to save time here. So from 0 to 2, the average rate of change is -4. From 2 to 4, the average rate of change is -1. What is the average rate of change from 6 to 8? So be careful. We like to do this where we skip an interval to make sure you're paying attention. We want to know the average rate of change from 6 to 8. Now, quadratic means this second difference is going to be the same. So we increase 3 to get to -1. We'll increase 3 to get to 2. We'll increase 3 to get to 5. So answer choice C. Again, if those intervals aren't nice and equally spaced and equal distant, then that means we messed up the problem. So they should work okay. But you'll have to pay attention. There's going to be a missing spot in there, or 2 or 3, and that's what you have to be careful about. Make sure you fill in the right spots. Number 16. For the polynomial function g, the rate of g is increasing for x is less than 2 and decreasing for x is greater than 2. Which of the following must be true? I don't know that a picture is necessary, but the rate of change of g, rate of change, that sounds like slope. So it doesn't mean that g is increasing and then decreasing. It means the slope is increasing and then decreasing. So the slope is getting steeper, less than 2, and then less steep, greater than 2. So maybe you could answer that without drawing a picture, but I'm going to try to draw a picture. My slope is getting steeper till I get to 2. So that's a steeper and steeper slope. At 2, my slope gets less and less. Something like that. Oh, I think my picture just showed what's happening there. I think I just found a point of inflection. It's not a min or a max. That would happen if g was changing from increasing to decreasing. But it's the rate of change of g, so the slope is changing. No, the slope isn't changing. The slope is increasing and then the slope is decreasing. Let's see, concave up for less than 2, concave down for more than 2. So answer choice D. Okay. Read carefully. Lost track. 16, 19. The values of the polynomial function are given in the table. If all the zeros of the function are given in the table, which of the following must be true? The f has a local minimum at -1, -36. I think a picture might be helpful. -1, -36. 1, 0. 3, 4. 5, 0. And 7, 12. And all the zeros are given. That means I can't cross the axis anymore. So that means I should be able to do a a rough sketch of this thing. Something like that. The f has a local minimum at -1, -36. No, because if it had a local minimum, that would mean it's headed back up, and then it would cross, so that's out. A local minimum at 5, 0. Yeah, that looks pretty good. Let's keep going, though. A local maximum at 3, 4. Uh-oh. My picture has a local maximum at 3, 4. Let's come back to that in a minute. A local maximum at 1, 0. Definitely not a local maximum at 1, 0. That's out. Okay, so B or C must be true.
Why wouldn't it be minimum at 136?
Because if it's a minimum at -1, -36, that would mean it comes back up and eventually would cross the x-axis. But all the zeros are given in the table, so I can't have another 0 over there. So it can't go back up, because then I'd have another 0. So it's got to be going down after that. But what about B versus C? Like, I sketched it like C was true, but I don't know that C is true. It's possible that it goes up through there and then comes down later. But it's absolutely true that 5, 0 is a minimum, because it turns around right there. So C is a maybe, but we don't want maybes, we want must. So B must be true, C is a maybe true. And I intentionally drew it misleading there. Okay, just as a word on timing, we took 17 minutes to work a third of the review. 17 times 3 is 51. And where did there's 23 multiple choice questions and 2 free response. So the test is longer than the review. So I guess we were still a little bit slower than we would need to be. But I was slowing down, explaining, over-explaining, answering questions. So, you can try to use the review as a pace to see if you're on pace. But I think we're going to be okay. Again, if you get stuck, don't spin your wheels forever on a problem. Go to a different one and come back to it.